Good evening, everyone. Let me share my screen first. Yes. Okay, my screen. I have shared my screen. My video is on. My mic is on. Okay. So let's start today's session. Welcome all of you for the fifth live interaction session for the NPTEL course MATLAB based programming lab in chemical engineering. So just small introduction. Myself, Prasil Kapadia. I have completed my BTech from SVNIT Surat in 2019. After that, I joined Reliance Industries Limited at Jamnagar and I worked there for a year. And mostly I worked there on SPEN. After that, I completed my master's from IIT Kharagpur. During my master's program, I learned a similar course on MATLAB from Professor Parag Deshpande. Currently, I am pursuing my PhD from IIT Bombay. This is my web page, LinkedIn page, and YouTube page. This is the YouTube link where all the recordings of these lectures have been uploaded. So till now, what we have covered? Till now, we have covered very basics of MATLAB. Then we learned how we can write a code. After that, we learned how to solve nonlinear equation using Newton-Raphson method. Then we check some inbuilt command like absol command, f0 command, and roots command. So till now, we have focused on this. So for this week and upcoming half week, we will be seeing how to solve linear kind of equations. So let's just first take the theory part. I will close my video. So and let me share my screen. My screen is already visible. Let me rotate my laptop. Yes. So what is a linear equation? This kind of equation we know y is equal to mx plus c. This is called linear equation. This kind of linear equation. So the general form of linear equation, let's say, is a11 x1 plus a12 x2. Just a minute. Plus, okay, let me rewrite this. The general kind of linear equations are a1 a11 x1 plus a12 x2 plus a13 x3 plus up to so on is equal to b1. Let's say it's a b1. And let's say my second equation is a21 x1 plus a22 x2 plus a23 x3 plus up to so on is equal to b2. Let's say my third equation is a31 x1 plus a32 x2 plus a33 x3 plus till n is equal to b3. Like, let's say I'm writing it my last row, an1 x1 plus an2 x2 plus an3 x3 plus, let's say my last column will be ann xn is equal to bn. Let's say these are my coupled linear equations that I want to solve. So if we see this equation, what can we imagine? These are the matrix. Sorry, these are matrix. So let's say I am writing a matrix. I can write this equation in terms of matrix. So let's say my left hand side matrix is coefficient of this first row. Let's say I'm just focusing on first row. So my first row is equation 1. Let's say that is a11 into x1 plus a12. I hope you know matrix multiplication. a12 into x2, so this will make sense, plus a13 into x3 plus up to, let's say, a1n into xn is equal to my first equation b1. Let's say my second equation is a21 x1 plus a22 into x2 plus a23 into x3 plus a2n into xn is equal to b2. Similarly, a31 x1 plus a32 x2 plus a33 x3 plus a3n xn is equal to b3. Let's say I am writing my last equation, a n1 x1 a n2 x2 plus a n3 x3 plus a n n into xn is equal to bn. So what I have done, I have converted this whole huge set of equation into matrix form. Let's say I want to solve these equations. So I will note down some methods. One is Gauss elimination method, then Gauss Seidel method, then another is LU decomposition method, and method, then Jacobi method, then one more inverse matrix method. This is simplest one. Method. So here, okay, let's start with a simple problem. Let's say I have three equation, a11 x1 plus a12 x2 plus a13 x3 is equal to b1, my first equation. Why I'm writing 1 1, that represents first row first column, a12 meaning first row, this is first row and this is my second column. Like that I'm writing my name of the coefficients. Then my second equation is a21 x1 plus a22 x2 plus a23 x3 is equal to v2, and my third equation is a31 x1 plus a32 x2 plus a33 x3 is equal to b3. Let's say I want to solve these three simultaneous equations. Just give me a why it's not working. Um, yeah, here. No, I don't want to open this. Mm, yeah, this one. Yeah. So let's say these are the three equations that I want to solve. So I can write these three equations in terms of matrix A11, A12, A13, A21, A22, A23, A31, A32, A33 into x1, x2, x3 is equal to b1, b2, b3. So let's say I want to find these coefficients. Let's say I'm writing this as a into this as x and this as b. Let's say ax is equal to b. How can I find x? X is equal to a inverse b. Simplest method, find the inverse of matrix A and multiply it with coefficient matrix. So this will give you solution. So this is nothing but inverse matrix method. But what can be the limitation? The limitation of this method is, what if inverse of matrix A is undefined? Let's say if we can't define our inverse of matrix, then what will we do? So this is the simplest method, but this is its big limitation. Okay, so let's say we are going for Gauss elimination method. So I will try to explain you this method with one example. Let's say my example is 2x1 plus 8x2 plus 2x3 is equal to 14 x1 plus 6x2 minus x3 is equal to 13, and 2x1 minus x2 plus 2 into x3 is equal to 5. Let's say I want to solve this equation using Gauss elimination method. So what I will do, I will first write down my matrix 2, 8, 2, 1, 6, minus 1, 2, minus 1, 2 into x1, x2, x3 is equal to 14, 13, 5. So what we do next, we write augmented matrix. Augmented matrix. So augmented matrix is matrix formed with your coefficient. So let's say my matrix was Ax is equal to B. So my augmented matrix is A comma B. Sorry, A comma B. This is my augmented matrix. So we are writing our matrix and its coefficients together. So this was my matrix and I am writing my coefficients here 14, 13 and 5. Okay. So let's say I'm getting this coefficient only. Let's say, okay, let me apply it. Okay, let's say I want my equation. Let's say I have this equation. Somehow, let's say we get that A33 double prime x3 is equal to b3 double prime. Then we can directly calculate x3. Then my second equation, let's say we get it in this term, a22 prime x2 plus a33 prime x3 is equal to b2. X3 from here we know, then we can multiply, we can substitute x2. If we can do something like that, it will be really easier to solve this equation. Okay, so let's say I want first this first coefficient, this term and this term to be equal to 0. So how can I keep this first coefficient is equal to 0? Let's write our first row as it is. Let's say I'm writing how do I get here 0? So what I need to do, I need to 1 minus, I am dividing this ratio 1 by 2 into 2. So this is how I can get 0. And here how can I get 0? It is direct, but ideally it is 2 minus this ratio 2 by 2 into 2. So what is this? Here I get 0, 0, 6. Okay, here also we need to change. So here it will be 6 minus 6 by 8 Sorry, here it will be 6 minus 1 by 2 into 6 into 8, sorry, and here it will be minus 1. My ratio is minus 1 by 2 into 2. So my this row will be 0, 2, minus 2, and my last 14. So here this will be 6. So what we are doing, we are multiplying with this row. We are keeping this row minus. I am defining this ratio 1 by 2 into 2. So this will be 0. So I am doing this for this whole row. Similarly, for this last row, what I will do, 2 minus, as it's 1. So let's just write it here 1. So my element is minus 1 minus 1 into 8. So here it's minus 9. And here 2 minus 2 by 2 into 2, it's 0. And here 5 minus 13. 5 minus 14 minus 9. Okay, so here by default you can get x2, but as we are seeing Gauss elimination method, what we need to do, we need to convert our matrix into this form, a11, a12, a13, 0, a22, a23, 00, a33. I need to form in this term. So here what I need to do now, I need to keep this term as 0. So how can I do this as 0? 2, 8, 2, 14, 0, 2, minus 2, 6. And here what I will do, this term is anyway 0. This term is 0. Let's say, um, okay, but here we can directly get. So what you need to do for Gauss elimination method, now you need to keep here one more 0. So how will you keep it one more 0? You will apply this same method. So here my equation is minus 9, x2 is equal to minus 9. So x2 is equal to 1. My next equation is 2x2 minus 2x3 is equal to 6. x2 is 1. So 2 minus 2x3 is equal to 6. x3 is equal to minus 2. And if we solve the first equation, we can get x1. So what we do, what we did here, that I want to show you. What we actually did here, for this part, what we did, we first defined some alpha, that is this ratio divided by this ratio, alpha 1, a21 divided by a11. And what we did, we replaced our row 2 with row 2 minus alpha times row 1. Then alpha 2 for this part, what we did, a31 by a11, and we defined R3, replaced R3 with R3 minus alpha times R1. Then what we'll do, we will again define our new alpha for the last column, last row. It's alpha 3, that is equal to a32 divided by a12, and we will replace R3 with R3 minus alpha 3 times R1. Okay, so this is how we can solve our equation using Gauss elimination method. So let's take this same example in MATLAB, and let's try to write down a code for Gauss elimination method. I hope this method is clear. Okay, so let's try to write down a code for Gauss elimination method. So I will just open my MATLAB. Sorry, here we will do it with this term, not here. It is A22, not A12. It is A22 and with R2. Okay. Okay. So this is how we solve it. Why did we choose this R2 term? Because here the first element is already 0. So we don't have to play. Okay. So let's try to solve. Let's first try. Let's first try to solve this problem. Let's first try to solve this problem using inverse matrix method. Okay. So we know how to define inverse of a matrix. Let's say I'm defining one matrix. A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is my matrix. And let's say I want to define inverse of a matrix. So we can use MATLAB inbuilt command directly to calculate inverse of a matrix. So it is defined by INV of A. So it will give me inverse of a matrix. So see, here it is written that matrix is close to singular or badly scaled. So results may be inaccurate. So this is not a good example, or this is not inverse of matrix may not occur. So let's say I'm just changing my matrix and see here. We can see the inverse of matrices. Just give me a minute.
Hello, sir. Sir, your mic is unmute.
Okay. From where you did not listen? Can you repeat? Hello. Can you please tell me from where you are not audible? I will repeat it. Okay, I will show you this Gauss, this matrix method again. So we write down our equation, and according to here, what we need to do for inverse matrix method, we need to find first inverse of a matrix and multiply it with coefficient matrix. So inverse of matrix. So first I calculated inverse of a matrix A using inv command, inv of A. Then I need to do inverse of A into B. So inverse of A into B we did, and we got a solution as this phi 1n minus 2. This is what we exactly got from uh, this hand calculations, correct, using Gauss elimination method. Let's say in Gauss elimination method, first we what we need to do, we need to first define our augmented matrix. Okay, so this is my augmented matrix where A and this columns are together. This A and B matrix are together. So let's say how can I, if I define my B like this, sorry, if I define my A, I put semicolon, so it will not work. So what I need to do, I need to just put one column. So what it will do, it will keep my A matrix as it is, and B matrix as it is, and it will just keep them together. So see, this is my augmented matrix created. So I am defining my, let's say I'm writing get augmented. I'm just putting one comment, augmented matrix. So augmented matrix, I am defining it where, let's say AB. AB is equal to A, comma B. So I have defined my augmented matrix. Okay, what now I what need to do? I need to put this two first, this coefficient to be zero. So how is it defined? R2 minus alpha times R1, and my alpha is A21 by A11. So let's first define first operation. So my alpha is defined as alpha 1, or you can just write it down alpha, whatever is fine. Alpha 1, what is my alpha? A21, this element divided by this element. So it is A augmented matrix AB is second row first column divided by augmented matrix first row first column. I have defined my alpha. And what I need to do, I need to repeat this operation, all columns, all elements. What I need to write, row 2 minus alpha 1 times row 1. So row 2 is my second row and all columns. Let's say I'm writing here, how have I defined? Okay, let's say uh, I is equal to, here I'm just writing A comma B. So let's say I'm defining I second row. I want to define my second row to second row, and when I put columns, so it will give all columns. So it will basically give me whole second row. So I need to divide this minus alpha times R1, alpha 1 times R1. So my R1 is alpha 1 into my R1 is augmented matrix row 1, that is first row, this column. Okay, so it will be my new augmented matrix. So I will not change the symbol, so it will, else it will be difficult. So this is my new augmented matrix second row. Okay, so similarly we need to do this operation for third row. So that is with same alpha, no, with different alpha. Here my alpha 2 will be, what is my alpha now? My alpha is From here, A 3 third row first column divided by first row first column. So my alpha will be augmented matrix third row first column divided by first row first column. And similarly, I will define my third row, new third row is equal to my new third row is equal to old third row minus similarly alpha 2 times my first row. Okay, so this is how. For better explanation, you can put one comment here saying R2 is equal to R2 minus alpha 1 into R1. So this is just for understanding. Similarly, R3 is equal to R3 minus alpha 2 times R1. Okay, let's just try to run this much code and see what we are getting. So my new augmented matrix will be this. So you can see that my second row is the way we want. Now in third row, we want here 0, not here. So we will now define, uh, I'm just writing it as second operation. Okay, so what I need to do, I'm defining my alpha 3 is equal to, now how can I make it 0? This I can make 0 by row 3 is equal to row 3 minus alpha 3 times row 2, and row alpha 3 is my A32 by A22. So A32 divided by A22. So this is my new alpha, and my new third row will be equal to augmented matrix third row whole columns minus alpha 3 times augmented matrix second row whole column. Okay, so what we expect from this operation, let's see, it should be in C. Here all zeros. So okay, let me write down this matrix for you and explain you how we can now proceed further. So my matrix is 2 8 2 14, 2 8 2 14, then 0 2 minus 2 6, 0 2 minus 2 6, 0 0 minus 9 and 18, minus 9 18. So my 9x3 is equal to 18. So x3 is equal to my 18 divided by minus 9. So I can define my x3 is equal to this augmented matrix third row and last element. So that is defined by and third row last element divided by augmented matrix third row third element. Is this correct? So I can write it down. I can write it down as, now let's say I'm just writing it here for solution. So my x3 is equal to, I will not write x3. I can write it x3. Okay, x3 is equal to augmented matrix third row last element divided by augmented matrix third row third element. So this should give me x3. Let's run it. So see, I'm getting x3 is equal to minus 2. This is what we should get here, minus 2. So now I want to define my x2. So 2x2 minus 2x3 is equal to 6. So 2x2 is equal to 6 plus 2x3, and x2 is equal to this divided by 2. So 6 is my augmented matrix second row last element or I will write it down here, minus of minus 2. So minus of augmented matrix second row third element into x3 whole divided by augmented matrix second row second element. Correct? So I'm just converting these maths into code. So I can write it down, my x2 is equal to augmented matrix second row last element minus augmented matrix from here. This is my minus 2 is second row second row third element, and that is multiplied with x3, and this whole term is divided by this whole term is divided by 2, that is augmented matrix second row second element So this should give me x2. Let's see what we are getting is x2. So I'm getting x2 is equal to 1. This is what we should get. Now x1 is equal to, okay, so let's say how I can define my x2 element. 2x1 plus 8x2 plus 2x3 is equal to 14. Correct? So my 14 minus 2x3 minus 8x2 divided by 2 is equal to x1. So my 14 is, what is 14? 14 is my augmented matrix first row last element, first row, and is given, so it will give last, so we don't need to count. Then 2 is, what is 2? Augmented matrix first row and should be third element. Correct? And 8 is my same augmented matrix first row second element, and 2 is augmented matrix first row first element. Okay, so this equation we need to convert it into code. So x1 is equal to augmented matrix first row last element minus augmented matrix from here, if you can see, first row third element into x3 minus augmented matrix first row second element into x2, and this whole bracket is divided by augmented matrix first row first element. Okay, so we'll get x1 x2 x3 pi 1 minus 2. This is exactly what we got from inverse matrix method. Let's say I'm defining x matrix is equal to x1 comma x2 comma x3. So it will just print. Okay, let me put it in column way. So it will just print values horizontally. 1 minus 2. So this is our solution. So this is how we can solve our equation using this Gauss elimination method, and this was inverse matrix method. Okay, in MATLAB there is one more facility. Okay, so what was the solution? Phi 1 minus t. If I write it here. Okay, so instead of defining inverse of A, what I can do otherwise, what I can do, let's say my x is equal to what I'm doing. If we see here, what if we see here, I'm writing x is equal to b divided by a. Correct? So what I need to do, I need to write a slash backslash b. This will also give me same answer, phi 1 minus 2. So instead of writing inverse, what you can do, you can write A, B divided by A. But if I am using this backslash, it's showing that A is inversed. So A backslash B. So this is how I can directly get my solution of coupled linear equation. So let's take one more example from this book and let's try to move ahead with one chemical engineering problem. So we will just discuss Gauss elimination method. We will not move ahead with other methods. So let's say this is one problem, I guess, but one complicated problem. So see here we have which yeah we solved this first problem. Okay, let's try to solve this second problem. 2 minus 2. So I will just write down coefficients. 2 minus 2 5 13. 2 minus 2 pi and 13. Then 2 3 4 20. 2 3 4 and 20. And my last equation is 2 3 minus 1 3 10. 3 minus 1 3 10. Let's say I'm trying it first using okay backslash operation. So I'm getting 1 2 3 as my solution. Let's see what book is giving. Are we getting 1 2 3 from book or there other different? So we are getting 1 2 3. Let's try to solve this equation using this inverse. We'll get same thing, but let's do it. So here also we'll get 1 2 3. And let's try to solve it using Gauss elimination method. So I'll just copy this A and B matrix and I will paste it here in my Gauss elimination code. So see, what should I get? I should get 1 2 3. Let's see if we are getting it or not. Okay, let me rerun it. Oh, it's going up. It is 1 2 3. So this is our solution using all three methods. Okay, so I hope this Gauss elimination method, uh, code of Gauss elimination method, this is just for 3 cross 3. We can simplify it code for any n cross n matrix. We need to use loops and common terms instead of writing this kind of equations. So this is what we need to do if you want to make general code for Gauss elimination method, but for at least 3 cross 3 equation, you can use this code. This is using inverse of matrix or using backslash operation. Okay, so this is how we can solve linear equations, simultaneous linear equations. So now let's move ahead. So today we will take one distillation unit problem. Just give me a minute. Uh, I will be back. Just give me a minute. We will take this distillation column problem. I will keep my Okay, I'm back. So I hope this Gauss elimination and inverse matrix part is clear. So we can move ahead with our today's problem statement of distillation unit. Okay, so let's read out the problem. In this problem, we solve the mass balance equations in a distillation column using MATLAB. The model equations are linear but coupled. So those are interconnected. The way equations we are solved, those are linear equations and coupled equations. Hence, one needs to solve simultaneous linear equations. We here what we did, this was one independent equation. This was one independent equation, but these two equations were coupled. So we need to solve these two equations simultaneously. So these are called simultaneous linear equation. Okay. Separation of benzene, toluene, styrene, and xylene is to be carried out in a distillation column as shown in the following schematic. So this is the schematic where distillation of benzene, toluene, styrene, and xylene. Benzene is 1, toluene is 2, styrene is 3, and xylene is 4. From the thumb rule, if we are having n columns, we need n minus 1 distillation columns. So here there are 4 components. So we need 4 minus 1, total 3 distillation columns. Okay. So here we can see that feed flow rate is 70 moles per minute and x1, x2, x3 and x4 is given. So from this first distillation column, distillate is being sent to this and bottoms is being sent to this, and from this 2 and 2 total 4 individual products are obtained. So D1, D2 and B1, B2 are distillate and bottom molar flow rates. It is in molar flow rates of column 2 and 3 respectively. The compositions of the feed and the exit streams are shown in the schematics. All these compositions of x1, x2, x3, x4 of all D1, D2, D1, B1, D2, B2 and these F streams are given to us. Now what is told to us? The process was running at steady state. However, due to the failure of master feed pump, the from where feed is being sent to this distillation column. So failure of the master feed pump, the feed rate drops from 70 moles per minute to 20 moles per minute in steps of 5 moles per minute. So what does this sentence mean? What is happening? My feed flow rate is dropping from 70 moles to 20 moles per minute in steps of 5. So what is happening? First it was 70, then in step of 5 it is reducing. So from 70 it is going to 65, then 60, then 55, 50, like that it is dropping till 20. But what is happening? The molar compositions of the distillate and bottoms remain constant throughout. So our compositions are not changing, only flow rates are changing. Assuming no transients in the system and equilibrium maintained at all the time. So even in this condition, we are assuming that, or the problem statement is saying that no equilibrium is ruined. So equilibrium is maintained. Report how the production rate of each product gets affected. So what they are saying, just because flow rate is reducing, composition is not getting affected, but our production is affected. That will be obviously affected because of overall mass balance. So we are supposed to show how this is getting affected. So what we need to do? What do we need to do to solve this problem? What do we need to do to solve this problem? Okay. Where is my pen? Yeah. So what do we need to do? We need to first write down mass balance equations. So can I minimize it? Yeah. So what will be my mass balance equation here? So my here mass balance equation will be overall mass balance equation is equal to F is equal to D1 plus B1 plus D2 plus B2. This will be my overall. I'm sorry, this will be my overall mass balance equation. Let's say I want to write down equations for component balance. Okay, I'm not writing it here. Let's write it in MATLAB with comment part. So, okay, let's first write down the equations and then worry about this feed rate is decreased from 70 to 20 moles per minute. Let's worry about that part later. So I will first write clear all CLC. Then, okay, first writing component mass balance. Component balance equations. I'm writing first component balance equation. So, okay, so what is my equation for benzene? F into 0.2 is equal to D1 into 0.35 plus B1 into 0.16 plus D2 into 0.21 plus B2 into 0.01. Is this clear? So let me write it down my first equation for benzene. So I will write it down in comment part only. So benzene, my equation is F into zero point 0.2 is equal to D1 into 0.35 plus B1 into 0.16 plus D2 into 0.21 plus B2 into 0.01. So this is the equation for benzene. So let's write down similarly it for our second component, that is toluene. Okay. So I will write it down for toluene. Toluene. The equation is F into 0.40. Second is my toluene. So F into 0.40. F into 0.40. We are not writing overall balance. We are just writing all four component balance. So we need four equations, four unknowns. Equal to D1 into 0.54. D1 into 0.54 plus B1 into 0.42. B1 into 0.42 plus, sorry, D2 into 0.54 plus B2 into its fraction that is given to us as, sorry, um, that is given to us as 0.10. Okay. Now our third component is styrene. Styrene equation is F into 0.25 is equal to D1 into 0.04 B1 into 0.24. D1 into 0.04 plus B1 into 0.24 plus D2 into 0.10 plus B2 into 0.65. This is my third equation for styrene. Now last equation is for xylene. So for xylene, F into, I'm sorry, F into 0.15, F into 0.15 is equal to D1 into 0.07 plus B1 into 0.18 plus D2 into 0.10 plus, okay, D2 into 0.15, not 0.10, plus B2 into last element, that is 0.24. Okay, so what we have done, we have first written our overall mass balance equation. Now what I need to do, I need to convert it in terms of equations. So what I will do, this is my matrix, one matrix is equal to this left hand side matrix, this one is equal to right hand side matrix. So let's say I'm just writing first all individual coefficients. So I'm writing benzene is equal to, I'm writing coefficient, those are in rows. So 0.35, 0.16, 0.21, 0.01. So this is my matrix. First row. I'm not writing whole matrix. I'm just writing first row. In my second row, toluene is equal to 0.54, 0.42, 0.54, 0.10. This is my second row. Now third row, styrene, styrene is equal, I'm just giving one name to avoid any confusion. Styrene is equal to 0.04, 0.24, 0.10, 0.65. And xylene is equal to 0.07, 0.18, 0.15, 0.24. Okay. Okay. So now what I need to do, I need to write down this as whole matrix. This whole matrix. So I'm just writing, let's say A is equal to first row. How will I write it? First row, second row, third row, fourth row. Right? So this is my first row. Then I will put semicolon for second row and third row and fourth row. Okay, so my A matrix is ready. Now I need to prepare my B matrix. So B matrix, what is my B matrix? Okay, so here also we are given compositions. So that is 0.20 here, if we can see here. So that equation is F into whole this term. Let's say my matrix A is equal to 1, 2, 3, 4, and I want to multiply my all elements with 0.5. So I will write 0.5 into A. So it will give me all matrix, all elements divided by 0.5. So here also what I can do, I can define my B matrix as F multiplied with 0.20, and it's in column 0.40, 0.25, 0.15. Let's see it here. Let's say I'm putting it in terms of columns and I'm doing 0.5 into A. So see, we got that. So here, okay, let's say first we are just assuming when what is the values when our feed flow rate, what is told to us, it is dropping from 70 to 20. So let's just say first my value of F is 70. And let's try to find out the solution. So how will I solve this? I will just write down, what should I write? Let's say C is equal to inverse of A into B. So this will give me my solution of B1, B1, D2, B2. So I'm coming out as 26.25, 17.5, 8.75, 17.5. Okay. Or you can do A backslash B. So that will also give you the same answer. Okay. Now, if you don't want to do all these things, so there is one MATLAB inbuilt command that is called linsolve. Linsolve, yeah. Let it open. I have pressed enter. So using linsolve command also you can directly find a solution. So it is better to use linsolve inbuilt command. So what is the syntax? X is equal to linsolve of A comma B, where your matrix is Ax is equal to B. Correct? So what you need to write? A comma B. So X is equal to linsolve of my A comma A is my actual matrix and B is my coefficient matrix. Okay. Ax is equal to B. So A is my actual matrix, B is my coefficient matrix. So I need to write down A comma B and see what we are getting. We will be getting the same solution. So it's better to solve this using linsolve command. Okay. So okay. Now our problem is not clearly completely solved. So what is happening? Feed rate is dropping from 70 to 20 in steps of 5. So what is happening? I have a F matrix also. My F is first is 0. First is 70, then it is going to 65, then it is going to 60. Let's say I'm just solving this for this three. Sorry. Yeah, here as F is a vector, I need to put one dot product dot symbol here. Okay, so it will do element by element operation. Yeah, so it will do element by element operation. So we have 3. Let's check it from here. So we have 4, 6, 470, 65, 60. We have this solution. But I don't want to do it like this. I want to generalize it. So how can I define my F from 70 to 60 in interval of 5? So what can I do? 70 to, it is dropping to 20 in interval of 5, but it interval of -5 because it is reducing. So I'll write -5. So see, we have 70, 65, 60, 55, 50 like that. So I will just define it as 70 colon -5 colon 20. Oh, I don't need it like this. I have to put one semicolon and see, you can see here F is printed. Okay. So see, I have my whole C matrix or solution matrix. So see, it's coming out for all values. Okay. So we have solved our coupled equation, but what are we seeing from here? We can't say anything from just solving the equation. So what is the better part to do here? We need to plot it. So for this kind of uh, stairs kind of plot where first it is 70, then 65, then 60. So we can use stairs command, stairs, stairs command for our plot. Okay. So it will produce one step graph. So stair, the syntax is same, stairs x comma y. So see here, it is one staircase. So let's just try to plot it for fluorids only. Okay. So let me comment it with plotting. So let's say I'm writing stairs. Okay. Now I am first plotting my fluorid. So stairs of fluorid is by F. I just need to write down F. So let's see what we are getting. Oh, plot will be here. See, it is like this. First it was 670, then 65, then 60, like that it is reducing. But now I want to see what is the product, how product is getting changed. So what I can do, I can write stairs. Let's say I'm just seeing for the D1. So what is D1? D1 is this 4C matrix. It is the first row, that is D1. So how can I define it? Stairs of C of first row all columns. That will give me D1. And let's say I want to keep it in red color. So I will just put dash R. Okay. And I will plot it. Okay. So what's happening? Okay. One thing, when you are doing your actual MATLAB, okay, so see, these two are different plots, but I want to keep them in one plot. So I need to write hold on. So it will hold this plot and then plot this. So let's see if I'm using hold on. So both will be plotted in a single plot. Okay, so see, you can see it. Okay, so now similarly do it for others. Matrix is second row, all columns. Let's say I'm keeping it with black color. Then again, hold on. Then stairs. Third row, all columns. And I'm keeping it with, let's say, B was blue, not black. I'm sorry. K is black. Hold on. Stairs. C of columns, comma. Let's say I'm keeping it green. Okay. Hold on. And let's say I'm keeping this one as red. But okay, let's say I'm keeping double dots. Okay. If I can open this in new image. Okay, this one is unrecognized. Okay, it's STAIRS. Now it should work. So see here, you can see if I can open figure in new window. Okay, will it open? Yeah, here you can see. So see, these are double dots for feed flow rate, and these are 1, 2, 3, and 4. I can't see because 4 is, what is the value of 4? Is that coinciding with each other? Some values may be coinciding with each other. Yeah, see this D1, B1, D2, B2, D2, B2, and B1 and B2 are coinciding. So we are just seeing three. Now here, from here, what can we say? What is F? What is B1? What is this X label? What is Y label? We can't actually understand anything from here. So we need to further modify our plot. So let's first give legend. So how can I give legend? So for legend, I will use legend command, legend, legend. Okay, so I need to put my legends accordingly. So for the first plot, what is the legend? First plot was calculation of D1. So I will put D1, comma. Second plot, this one was for B1. Then third one was for D2. And fourth one was for B2. And this fifth one is for F. Okay, let's say I'm giving X label. Okay, we have not chosen anything for X. But let's say by default it is taking, let's write something as it is varying with time. And Y label, Y label, let's say production rate in units of moles per minute. Let's say I want to give chart title. So it is done by using title command. So I can write this title production rate. Okay, and now let's run this and see what we are getting. So see here, I will open this plot in new. So see, this one is looking better. So this is from here we can see this is D1, B1 and B2 are coinciding, so we can't see both together. B1, D2, B2, and this one is F. So this is how we can plot. Let's say I want to see what is this value. So let's say if here there are some lines, it will be useful, right? So we can also keep grid on. It will open, it will create some lines. Okay, let's say if I'm selecting this. So see, there are some light lines. So it will be useful to see this is 2, this is 3, this is 4, fourth step, fifth step. So this is better. This is better represent. You can even play further and you can improve quality of your graph. So this was the problem from our chemical engineering background of mass balance of multi-component distillation column. And we have solved these equations using linsolve command, a slash b inverse of matrix. So this is how we can do that. Okay, so now where did it go here? Sorry. Okay, so now let's move ahead. So let's take some questions. Okay, this problem we'll see for next week, not today, because it's one a long problem. Okay, so my question is, Gauss-Elimination is an algorithm for solving systems of linear equations. We know that LU decomposition can be viewed as the matrix form of Gauss-Elimination, which resolves the coefficient matrix as the upper of lower and as the product of lower and upper triangular matrices. Compute the lower triangular matrix L using LU inbuilt function for this matrix. So my matrix is, I will do it here, or I can do it here. So A is equal to 1 to 1, 3 to 1, 1, 0, 5. This is my matrix A. And I am supposed to use LU inbuilt function. So let me search LU function. So what is the syntax of LU function? So LU, L comma U is equal to LU of A. So lower, this is lower triangular matrix, this is upper triangular matrix. I just need to write U of A. So let's say I'm writing let's see what we're getting. So see, this is lower upper triangular matrix and lower triangular matrix. Sorry, this is lower triangular matrix where all zeros are at up, and this is upper triangular matrix where all zeros are at down. Okay. So if I multiply L with U, I should get my original matrix, correct? And let's see. See, it is 1 to 1, 3 to 1, 0, 5. So this is how you can estimate. So what was asked to us? Matrix L. So which one is my matrix L? My matrix L is this first one, correct? 0.333101000.333 minus 0.51. So this was our first problem. Okay, now let's take second problem. Compute the product of eigenvalues of matrix M using inbuilt MATLAB functions eig and product. So I'm first supposed to find eigenvalues and then product of eigenvalues. Okay. So how do we calculate eigenvalues? So let's say I am having my matrix A. So what do I need to do to calculate eigenvalue? I need to A minus lambda into identity matrix is equal to 0. So my your matrix, let's say, is A11, A12, A13, A21, A22, A23, P1, P2, A33. This matrix minus lambda times identity matrix 1 0 0 0 1 0 0 0 1 is equal to 0. So this one E11 minus lambda A12 A13 A21 A22 minus lambda A23 A31 A32 A33 minus lambda is equal to 0. So this is determinant and all these coefficients we know, so we can calculate eigen values. So in MATLAB we don't need to write down everything. We can just directly call inbuilt function what they have told in question. Inbuilt functions eig and prod product. So let's just see eig. So see, eig of A will give you eigen value. So I just need to write eig of A. So, okay, let's take this problem. Let's first write down the matrix. Let me do this thing first. Okay. Now I will first define my matrix M from problem statement. That is this one. That is 1 minus 1 4 semicolon 3 2 minus 1 semicolon 2 1 minus 1. Now I want to find the eigenvalues of this matrix. So how will I find? I will write eig of, sorry, eig of M. My matrix is M. So these are my eigenvalues. Now what is told to us? Compute the product of eigenvalues. So product is simply minus 6, but we are not supposed to directly do it using MATLAB inbuilt function prod. So what I can do? Okay, let's search for prod. So it will just give you product of A. So I want product of this eig. Let's say I'm defining this as E. Okay. I want, let's say, P is equal to prod of this E matrix. So I'll get answer as minus 6. So our answer will be minus 6. Compute the rank and determinant of the following matrix using suitable inbuilt function in MATLAB. So let's first see rank of a matrix. So I'll just write rank. So rank, when I write rank, it will give me rank of a matrix. So see, rank of A, it will give me rank of matrix. So my matrix is this one. So I will write down M is equal to 0 0.7, 0 0.5, 0 0.4, then 2, 1.8, 0.3, and 0.6, 1.9, 1.6. Okay, so this is my matrix M. Now I want to find a rank. So how can I find rank? Rank of M. Okay, let's see what we are getting. Okay, rank of this matrix is 3. Now I want to calculate determinant. So let's just write determinant. So we will see what is the inbuilt command to calculate determinant. So that is DET, det. So I just need to write DET of A. That will give me determinant. Okay. So I will write DET of M. That will give me determinant of M. So that is coming out to be 2.2350. Whatever is the answer. Okay. So this was our third question. Now let's move ahead with the fourth question. Consider the following system of linear equations represented as Ax is equal to B. We have three equations, three unknown. We need to say if the system has unique solution or infinite number of solution. Okay. So first, let's write down this matrix. A is equal to 1, 1, minus 1, 1, 2, minus 0.5, 1.5, 1, 1. So first equation 1, 1, minus 1. Second equation 1, 2, minus 0.5. And third equation 1.5, 1, 1. Now let's write down coefficient matrix B, that is 5 minus 1 to 5 minus 1. My solution or capital X is equal to, we'll use linsolve A comma B. So see, I'm getting one simple answer. Okay. Let's say I'm making first and second equation same. So this one is a unique solution, right? I'm making identical equations. Matrix is singular or not singular to work precision because these two rows are same. So how can we say it without doing this? So we know that there are three number of unknowns in our equation. So what we need to do, we need to find the rank of the matrix. So first I need to define my augmented matrix A comma B, and I want to find rank of AB. So see, in this case, my rank of AB is 2 and my number of unknowns are 3. That's why it will have infinite number of solution. But let's say for this problem, our second equation is 1, 2, minus 0.5. 1, 2, minus 0.5, and this coefficient is minus 1. So let's say what is the rank? We should get rank as 3. Number of equations. So see, rank is 3, number of equation is 3. So system will have infinite, not infinite, but system will have unique solution. Okay, so this is how we can do this. Now, okay, now next question. Oh, big one. The material and energy balance equations in a single effect evaporator which concentrates fruit juice are given as total balance MF minus MP minus MV is equal to 0. Energy balance 44.9 MF minus 65.1 MP minus 1113.7 MV is equal to minus 952 into 10 raised to 3. and solids balance is 0.1 mf minus 0.55 mp is equal to 0, where mf, mp and mv represents the mass flow rates of feed product and vapor, the value of mv. Okay, so let's first write down our equations. First equation, 1 mf minus 1 mv mp minus 1 mv is equal to 0. This is my first equation. My second equation is 44.9 mf minus 65.1 mp minus 1113.7 into mv is equal to minus 952 into 10 raised to 3. And my third equation is 0.1 mf minus 0.55 mp is equal to 0. So we need to solve these three equations. Okay, so write down matrix A. So my first equations, coefficient of mf is 1, mp is minus 1, mv is minus 1. I will put one semicolon and I will write down my second equation. So mf is 44.9, mp is minus 65.1, and mv is minus 1113.7. I will put one semicolon. My third equation, mf is 0.1, mp is minus 0.55, mv is 0. So this is my matrix, left hand side matrix. Now my coefficient matrix B is equal to coefficient or not coefficient matrix, actually right hand side matrix. First one is 0, then I will put one semicolon. Second one is minus 952 into 10 raised to 3 and 0. Let's solve this using linsolve, or we are not told anything, so let's try to solve this using linsolve command. So let's say my m is equal to linsolve of p. So my first value is mf, second value is mp. So and third value is mv, and I am told to ask give the value of mv. So my value of mv is 0.8870 into 10 raised to 3. So my exact answer is 887. Correct. Here what I can do, instead of writing it like 10 raised to 3, I can just write e. If I write 5 to e3, so it will give 952 into 10 raised to 3. Okay. Student, just give me a minute. Okay, let's move ahead with the next problem. Okay, so we are supposed to solve these equations, set of linear equations. Let's solve this. Okay. My first equation is x1 minus 2x2 is equal to 3. x1 plus 2x2 plus x3 is equal to minus 2. x2 plus 2x3 minus x4 is equal to minus 2. x3 plus 2x4 is equal to 1. So we have 4 equations and 4 unknown x1, x2, x3, x4. So in first equation, coefficient of x1 is 1. Coefficient of x2 is minus 2. x3 and x4, those terms are not present. So their coefficients are 0, 0. Correct? My second equation, coefficient of x1 is 1. Coefficient of x2 is 2. Coefficient of x3 is 1. Coefficient of x4 is 0. Now my third equation, coefficient of x1 is 0. x2 is 1. x3 is 2 and x4 is minus 1. So 1, 2, minus 1, 2, minus 1. Now my last equation, x1 and x2 0. x3 1, x4 2. Correct? So this is my A matrix. Now my B matrix, right hand side matrix, that is 3 minus 2 minus 2 1. 3 semicolon minus 2 minus 2 1. Okay. Okay, let's first use this inverse of A command. x1 is equal to inverse of A into B. Now let's use second method. x2 is equal to A, then backslash B. Let's use third method. x3 is equal to linsolve. We should get same answers, right? B. So I'm running it. So see here, x1, x2, x3. So x1 point, from using 0.5556 minus 1.22 minus 0.11, 0.55. Same answer we are getting from all these methods. So what we are supposed to say, x2 rounded to the nearest digit. So that is minus 1.2, or nearest digit. So that is minus 1, rounded to the round off to the nearest digit. So minus 1.2, nearest digit is minus 1. Okay. So our third question, seventh question. Seventh question. Solve the following set of linear equations and report the value of x1 truncated to one figure after decimal. Okay, so these are equations. 7x1 plus 9x2 plus x3 is equal to 6. 6x1 plus 4x2 plus x3 is equal to 4. 3x1 plus 9x2 plus 3x3 is equal to 2. So my equations are A is equal to 7, 9, 1, 7, 9, 1, colon, then 6, 4, 1. In my third equation, 3, 9, 3. My B matrix is 6, 4, 2. 6 semicolon 4 semicolon. So let's solve same way. x1 is equal to, using all three commands. Let's try to solve it. So x1 is equal to inverse of A into B A backslash B, and let's use linsolve. Okay, so I have used all three methods, and let's see what is the result that we are getting. Okay, so my answers are this 0.611. Okay, let me open all three. Sorry, 0.611, 0.277, 0.778. Now what we are told, truncated to one figure. So 0.611 will be truncated to one figure. So it will be zero point 0.6. Okay. After decimal. So 0.6 is my correct answer. Let's solve this using that Gauss elimination method. So I will just copy this matrix here in Gauss elimination method. Are we getting something same or not? So see, I'm getting 0.611, 0.277 minus 0.77. So we are getting exactly same answers. So this is how we solved it using inverse of matrix inversion. A slash B, those two are actually same. Then linsolve and then using Gauss elimination method. So answers won't affect. Okay, my next question, sorry, is here. Okay. A manufacturer plans to prepare a 1 kg of chemical compound by blending three enamels A, B, and C. The amount of these enamels in the new compound are X, Y, and Z, respectively. Three pigments P1, P2, P3 are necessary for the new compound for the desired percentages of these pigments in the new compounds are 40% P1, 27% P2, and 33% P3. So weight percentage of pigments in A are 80% P1, 20% P3, 70% P2, 30% P3, and 30% P1, 15% P2, and 55% P3. So let's try to write down our equation first. Mm. So in solution, it is here it's 0.80 P1, no P1, 0.30 P1. So I will write it down as in total 40%. So 0.80 in first solution, that I'm saying it as x, plus 0.30 in last one, that is said, is equal to total is 0.40. Because our basis is 1 kg, so I need to multiply 0.40 into 1, so it is same. My second equation will be, from here there is no P2 here, so it is 0.70 P2 plus 0.15, so 0.70 x plus 0.70 y plus 0.15 z. And my third equation is 0.20 x plus 0.30 y. Okay, so just for sake of understanding, write it like this. Okay, so now it's easy to understand. My coefficients, A is equal to 0.80, 0, 0.30, 0, correct? My matrix B is this one. Let's try to solve this like all three E backslash B x3 is equal to A comma B. So let's see what I am getting. I have x1, x2. All three methods will give same answer ultimately. So what I am asked, value of y truncated to one figure after decimal. So it is 0.3, correct? So we are getting same answer from all these three methods. Let me copy this here into Gauss elimination method. We'll get same answers. So see my X matrix, same answer we are. Okay. So my next question. For multi-component distillation, Underwood equations are used to determine the maximum reflux ratio. This is completely wrong. Underwood equation is used to determine minimum reflux ratio. If you know FUG method, F is Fenske equation. Fenske is used for determining minimum number of theoretical trays. U is this Underwood equation for minimum reflux ratio, and G is Gilliland equation, that is number of feed tray location. Okay, so a correct answer is minimum reflux ratio. So this statement is not correct. So it is false. Here, 10th, liquefied petroleum gas used for the household cooking comprises mainly of, is it propane, butane, ethane, methane, ethane, or methane and carbon monoxide? So the correct answer is propane and butane. LPG is combination of propane and butane. If you want to see the uh, composition of LPG. So LPG, okay, this is ChatGPT answer or AI answer. Propane, butane, highly flammable mixture. Okay, I just want to see that percentage if they have given. Okay, 85% minimum. See, 85% minimum propane by volume. Maximum is propane, and then rest are others. So our answer is propane and butane. Next question. Multi-component distillation separates crude oil based on different dash of compounds in the mixture. So this is based on difference of relative volatilities, or other in our general words we say based on the difference in normal boiling points. So answer is correct answer is C, relative volatilities. Equation 12, the major advantages of using vacuum distillation unit VDU in refineries is or are. Okay, vacuum distillation unit is generally used when we have to go for uh, our boiling point is extremely high. The component's boiling point is extremely high. So vacuum distillation, what we do, we apply vacuum. So we are basically reducing pressure. So what happened when we reduce the pressure, boiling point also gets reduced. So because of this, what happens? Ability to distill compounds with higher boiling points is increased. Yeah, correct. Because it is able to distill compounds with higher boiling points, because we are applying vacuum, so boiling point has reduced operating cost. Operating cost is not going to reduce, it is actually going to increase because of applying vacuum. Then this is not correct option. Increased yield, yes, yield will increase. And prevention of product degradation due to reduced pressure, this also we can do. So our correct answers are A, C and D. Correct. Now next question. Which of the mentioned below not a process of obtaining gasoline? cracking, polymerization, alkylation, or casting. So cracking, catalytic cracking is done. Polymerization to convert ethane into polyethylene, alkylation, and casting. So casting is mainly used in the processes related to metal. So our correct answer is D, casting. Now, next question. The simplest member of organic compounds is methanol is CH3OH, methane is CH4, formaldehyde is HCHO, and formic acid is HCOOH. So simplest one is methane with one carbon and four hydrogen. So correct answer is methane. Now 15th, scalars can be declared with or without square brackets. So let's say I'm defining scalar. A is equal to 1. This is scalar. So I can define it with without bracket. So that is correct. I can also define it without with bracket or without bracket. So we can define it in both way. So answer is true, but we don't need to include any brackets when we are defining scalar. Okay, so correct answer is true. Okay, now let's take some more problems from this book. Let's try to solve this problem. 2x1 minus 2x2. I guess it's not the same problem. Let me check it. Yeah, it's not the same one. So 2x1 minus 2x2 using matrix inversion method. So let's write down the coefficients here. Inverse matrix. So let's do it here. So my A is equal to my first equation 2 minus 2 5. My second equation 2 3 4. My third equation 3 minus 1 3 3. Okay. And my matrix B is equal to 13 20 10. 10. Now I want to solve this using matrix inversion method. So I need to find inverse of A and then I will multiply it with B. So let's see what we are getting. I'm getting 1 2 3. I should get 1 2 3 or not. Let's check from here. It is 1 2 3. Okay. Let's say I'm doing this A slash B. Same answer 1 2 3. Let's try to solve this using Gauss-Elimination method and see what we are getting. Oh, same answer 1 2 3. Okay. Try to solve these more problems because I guess this is something that you are going to get in your exams. Let's try to solve this problem. I guess it's the same one, right? Let's take this one. X1 plus x2 plus x3 plus x4 is equal to minus 1. So my matrix A is first equation A is equal to 1 1 1 1 1 1 1 1. B is equal to 4 5 6 7. C is equal to 6 10 15 2. 6 10 15 2. And last one is 12 30 60 105. 12 30 60 10. And my this was my A matrix. Now right hand side B matrix is equal to -1 and all zeros. -1, 0, 0, 0. And let's see what we are getting. We are getting weird solutions. Okay, so let's try to match it with book. -35. These are not accurate answers. No, we are not getting these answers. Okay, we need to repeat this until we are getting accurate answers. So this is Gauss-Jordan method. So Gauss-Jordan is iterative method. So this is just answer from one iteration. Okay, so this is the correct answer that we should get. Let's take one more example. So first, these three questions. 21 minus 2. Minus 2. Second equation. 320 minus 1. Third equation. 2 minus 320. Okay, my B matrix is 17 minus 18, 25. Okay, so we are solving this using all three methods. Okay, there is one issue in matrix multiplication. Okay, here it should be colon, semicolon, because it's in individual rows, correct? 1 minus 1, 1. Let's try to check it using Gauss-Elimination method. Same answer. Okay, let's take one more example and then we can stop. So these are iterative methods, okay? So let's take this example. 10, 1, 2, here. 10, 1, 2, 2, 10, 1, 2, 10, 1, 1, 2, 10. 1, 2, 10. My B matrix will be 44, 51, 61. 44, 51, and 61. I'm getting 3, 4, 5. Simple solution. 3, 4, 5. Let's do it using Gauss elimination. We will get same answers. So this is really simple. You can get this kind of questions in your final examination. So just practice it. Okay. So let's say I want to find eigenvalues of A that we have already checked. So let's do it. Eigenvalues of matrix A, eig of A. Okay, so one is real number and two are imaginary numbers. Okay, and let's say I want to find product of eigenvalues of A. So I am getting it as not A, sorry. Let's say I'm writing it here as E and P. So this eigenvalues product E. Sorry, I'm getting it something as 9.49 into 10 raised to 2 plus this minus 14i. So this is not, this is 0 only. So we are getting as 949. Okay, so this is all for today's class. So what we learned in today's class, in today's lecture, we learned how to solve simultaneous linear equations. So to solve that simultaneous linear equations, various methods are available. Gauss elimination method, Gauss-Seidel method, Gauss-Jordan method. Gauss-Jordan method is iterative method, then matrix inversion method. So among these, we first looked at matrix inversion method. We need to define inverse of a matrix so that we can do, then we can inverse of matrix into right hand side matrix B, that will give you the solution. Then further, what we have learned, we have learned Gauss elimination method. So for three equation, three unknown system, we have written our code to find a solution for solution using Gauss elimination method. Then further we checked how to calculate eigenvalues of a matrix and product of eigenvalues using eig command and prod command. We also checked how to find determinant of a matrix using det command. Then this all we learned. After that, we applied our knowledge to one chemical engineering problem where we were given benzene, toluene, styrene and xylene in our feed, and we were supposed to we were given three distillation columns, and there were four components, so four equations, four unknown. We solved it. Then we further learned that when fluoride was reducing from 70 to 20 in step of 5, so we learned how to plot stair chart using MATLAB. So in today's class, we learned this. In next week class, we will solve this particular problem of heat balance or heat transfer through a cylinder. This problem we will be seeing in next class. So this is all from my side for today's lecture. If anyone is having any query, please feel free to send me an email on this particular email ID. I will try to respond you as soon as possible. If you have any query, please feel free to write me down. Okay, so this is all from my side in today's lecture. In next class, we will see, as I told, we will see that heat transfer through the cylinder problem, and we will move ahead with initial value problem where for time t is equal to 0, some values is given. So we'll solve some coupled ordinary differential equations. Okay, so this is all for today's class. Thank you, everyone. Let's meet next week.